If you like the video, please subscribe Technical PCT channel and click the bell icon to get the latest videos.
So good morning students. Welcome to Sri Chaitanya PU College online classes. We are discussing about spherical mirrors. Yesterday we derived the relation between the focal length and radius of curvature. The relation between the focal length and radius of curvature is given by R is equal to 2 into F. In case of mirrors, spherical mirrors, either concave mirror or convex mirror, relation between the radius of curvature and focal length of the mirror is given by R is equal to 2F. R is the radius of curvature, F is the focal length. This can also be written as, if I want to calculate the focal length, F is equal to R by 2. The focal length of the mirror depends only on the radius of curvature. It is independent of the medium in which the mirror is kept. Mirror is kept. Though the medium gets changes, the radius of curvature will not change. The focal length will not change. So F dash is equal to F itself when the mirror is dipped inside a liquid. It may be water. It may be any liquid. F, it is the focal length when it is kept in air. F dash, it is the focal length of the same mirror when it is kept in a liquid. Focal length will not change. It remains the same because the focal length depends only on the radius of curvature. The radius of curvature will not change if the medium changes. Up to this, yesterday we discussed. Now we will move on to the next concept, that is formation of images by concave mirror when object is kept at the different positions in front of the mirror. What is the concept which we are going to discuss now? The images formed by the concave mirror when the object is kept at different positions in front of the concave mirror. Let us consider the concave mirror. This is the concave mirror, discussed a number of times in the previous classes. The outer surface is the polished. The inner surface is the reflecting surface. P is the pole of the mirror. F is the principal focus. C is the center of curvature. Center of curvature. Now we will keep the object at different positions in front of the concave mirror and we will identify where the image is formed and also what is the nature of the image. Nature of the image means whether it is real image or virtual image, whether it is erect image or inverted image. What happens to the size? In the nature, we will discuss 3 points. First one, whether the image formed is real or virtual. Second one, in the nature of the image, whether the image is erect image or inverted image. Third one, what happens to the size of the object, whether it increases or decreases, whether it is greater size of the image greater than size of the object, less than the size of the object, or equal to the size of the object. We have to identify. First of all, the object is kept at infinity, minus infinity, object position U, image position V in front of the mirror, object distance represented by U, image distance represented by V. First position, object is at minus infinity, where the image is formed. What is the nature of the image? In the yesterday's class, we discussed how to form the image. Out of 4 diagrams, we can take any 2. After refraction, those 2 refracted rays will intersect at a point. At that point, the image will be formed. Now, from this diagram, we can see where the image is formed. Ray diagram also. So, I will take the first light ray passing through what? Center of curvature. Yesterday we discussed when the light ray passes through the center of curvature, the light ray is reflected back. Why? Any line drawn from the center of curvature to any point on the mirror, it is the normal. In case of normal incidence, the reflected ray retraces the path. Retraces the path. This is the first one. First light ray, which I will take in order to form the image when the object is at infinity. Let us consider the second light ray, which is coming from the object. So it falls at the pole of the mirror. Pole of the mirror. Then after reflecting, it makes same angle according to the law of reflection. Angle of incidence is equal to angle of reflection. This is the first light ray. This is the second light ray. After refraction, they are going to intersect at a particular point. At that particular point, image will be formed. This is the point at which the 2 refracted light rays are going to intersect with each other. So at this point, what will be formed? Image will be formed when the object is kept at infinity. So from the diagram, it is very clear that the image is formed at the principal focus. Principal focus. So if the object is kept at infinity, the image will be formed at the principal focus. What will be the nature of the image? If we see the ray diagram, we can understand the image is the real image. Why the real image? The image is formed due to the convergent rays. Convergent rays. Really, the light rays are meeting at this point after refraction. So real image. Image formed is a real image. Inverted image. Inverted image. Very, very small compared to the size of the object. Size of the object. Object. First position is over. What is the first position? When the object is kept at infinity, minus infinity, where the image is formed. The image is formed at the principal focus. What is the nature of the image? Real image, inverted image, very, very small compared to the size of the object, diminished image, what we will say. So the first position was over. Second one, when the object is kept just beyond the center of curvature, just beyond center of curvature, where the image will be formed. And what is the nature of the image? What will be the nature of the image if the object is kept at the center of curvature? Let us draw that is the ray diagram. Ray diagram. Principal axis. This is the principal focus. This is the center of curvature. The object is kept just beyond the center of curvature. Center of curvature. Where the image will be formed. I will take the two light rays. Then after refraction, where they are going to intersect, I will find wherever they are going to intersect at that particular point, the image will be formed. The first light ray parallel to the principal axis. Parallel. We know the rule. If the light ray is parallel to the principal axis, after reflection, it has to pass through the principal focus. Principal focus. What is the second light ray? The second light ray, we can take any one. Let us consider the same one. I will take the light ray which falls at the pole of the mirror. After reflection, this is the reflected light ray. Reflected light ray. This is the first incident light ray. This is the second light ray. After reflection, they are going to meet at this point. After reflection. So here, what will be formed? Image will be formed. Image formation. Image formation. AB is the object. AB is the object. A dash, B dash is the image. When the object is kept beyond the C, beyond the center of curvature, that is the ray diagram for second position. Second position. So if we see properly, the image is formed in between center of curvature and the principal focus. And the principal focus. So image is formed between what and what? Between principal focus and the center of curvature. And the center of curvature. So if we see the diagram, ray diagram properly, the image, it is what kind of image? Real image only. Why real image? Because the image is formed due to convergent rays. And also, it is inverted image. Slightly, the size increases. Size. So, at this position, real image will be formed. Inverted image will be formed. The size, smaller in size. First one, very, very small, diminish. Here, small, means slightly the image size increases. This is the second position of the formation, image formation by concave mirror. In all the derivations, we have to follow this rule. Now let us consider the third position. Third. What is third? The object is kept exactly at the center of curvature. Exactly at the center of curvature. We will see where the image is formed and what kind of image will be formed. If the object is kept at the center of curvature, as usual, we will take the two light rays, incident light rays, after reflection, wherever they are going to intersect, at that particular point, the image will be formed. Image. So this is principal focus, center of curvature. Now the object is kept exactly at center of curvature. AB is the object. Very important table in optics. Object AB. Where the object is kept exactly at the center of curvature. How to form the image? Any two light rays by using rules, formation of image. First light ray parallel to the principal axis. First incident light ray. We know the rule. According to the rule, the light ray after reflection, it has to pass through the principal focus. Principal focus. Let us consider another light ray passing through the principal focus. Slightly I am changing. Previously we took the light ray falling at pole. Need not to be taken. The same light ray. The second light ray passing through what? The principal focus. After reflection, it passes parallel to the principal axis. Second light ray. These two light rays are going to intersect at a particular point. Identify that point where they are going to intersect. Here they are going to intersect. At this particular point, what will be formed? The image will be formed. Image. So image coincides with what? Object. B and B dash will coincide. Means what? When the object is kept at the center of curvature, where the image will be formed, the image will be formed exactly at center of curvature only. Center of curvature only. What will be the nature? Nature. See the image. The image is formed due to convergent rays or divergent rays. Convergent rays. Really the light rays are meeting at this point. So what kind of image will be formed? Real image will be formed. Inverted image will be formed. Inverted. And what size? Same size. Same size. Very important point. Third one. When the object is kept exactly at the center of curvature, the image will be formed exactly at center of curvature. What will be the size? Same size. If the object size is 10 centimeters, image size is also 10 centimeters. No need to do the problem solves. While solving the problems, if the object is given at center of curvature, some size, some length, 3 centimeters, 5 centimeters, 10 centimeters, no need to do the problems by formula. Directly we can say that the image is having same size as that of the object. As that of. If you observe properly, what we are doing, we are moving the object from infinity towards the mirror. If the object is moved from infinity towards the mirror, the image is moving from mirror away from the mirror. Initially, it is at minus infinity. Object. Image is formed at principal focus. Object is kept beyond the center of curvature. Image is formed between principal focus and the center of curvature. Object is kept exactly at C. Exactly at center of curvature. Image will be formed exactly at C. Of what size? Same size. Real image, real image, real image. Inverted, inverted, inverted. But what is the difference? Size is slowly increasing the size of the object. Now consider the fourth position. The fourth position is nothing but the object is kept between F and C. Between F and C. Principal focus and the center of curvature. Where the image will be formed, we have to identify by using same concept of ray diagram. Ray diagram. Consider the object. What is the object? AB is the object. Principal focus. This is the center of curvature. AB is the object which is kept in between the center of curvature and the principal focus. Principal focus. Take any two light rays from the rules. We know the rules, how to form the image. Out of 4, take any 2. The common one for all images, the light ray parallel to the principal axis, falls on the mirror. After reflection, passes through the principal focus. Passes through the principal focus. This is the first light ray. Now, consider the second light ray. Second light ray. The light ray falling at the pole of the mirror. Pole of the mirror. After reflection, these two light rays are going to intersect at this point. After reflection, the light rays are going to meet at this point. At this point, what will be formed? Image will be formed. So at this point, draw the image. A dash, B dash. A dash, B dash is the image. When the object is kept in between the principal focus and the center of curvature. Center of curvature. From the ray diagram, it is very clear that the image is formed beyond the center of curvature. Beyond. So image, it is formed where? Beyond the center of curvature. And also real image, inverted image, size larger than that of object. Larger than that of object. So it is also the real image, inverted image, size large than that of what? Than that of the size of the object. So 4 positions over. Still 2 positions are there in case of concave mirror. First one, minus infinity. Image at principal focus. Second one, beyond C. Image position between F and C. Third one, exactly at C. Exactly. Then image exactly at C. Fourth one, between F and C. Image will be formed beyond C. 4 images, real images, inverted images. Slightly, the size of the image goes on increases. At first position, size is very small. Next, small. At exactly C, same size. At that is the 4th position, larger in size. Now let us come to the 5th position. 5th position. What is the fifth position? Fifth position. It is kept exactly at principal focus, where the image will be formed. Exactly at the principal focus. Ray diagrams. So first, this is F, principal focus. This is the center of curvature. We have to keep the object exactly at what? Exactly at principal focus. AB is the object. A, B is the object. Kept at what? Kept at the principal focus. As usual, consider the two light rays. One light ray parallel to the principal axis. If the light ray is parallel to the principal axis, after reflection, it passes through the principal focus only. The first light ray. Now consider the second light ray, which is falling at the pole of the mirror. Pole of the mirror. This is second light ray. Then, after reflection, it follows the law of reflection. Angle of incidence is equal to angle of reflection. These two light rays will meet at infinity. They are parallel light rays. They are parallel light rays. They will meet at the infinity. So if the object is kept at principal focus, exactly, where will be the image formed? The image formed infinity. Infinity. What kind of image? Real image. Inverted image. Inverted. Very large in size. Large in size. Magnified. Magnified image. Magnified means what? The size of the image greater than the size of the object. Diminished means what? The size of the image less than the size of the object. 5 positions over. Last one. Last, sixth position. Where the object is kept. The object is kept in between the principal focus and the pole of the mirror. Kept between F and P. What is F? Principal focus. What is P? The pole of the mirror. Then where the image will be formed? Where the image will be formed. Image will be formed. So first, have the principal focus, center of curvature, ray diagram, object AB, which is kept in between the principal focus and the pole of the mirror. As usual, the two light rays we have to consider. Then we have to find the position of the image. First light ray, parallel to the principal axis. If it is parallel to the principal axis, where it should travel? It should travel, that is, passing through the principal focus. Principal focus. Another light ray, passing through the center of curvature. Center of curvature. We know if the light ray is passing through the center of curvature, normal incidence. Normal incidence means what? It falls on the mirror, once again reflected back. Reflected back. Then the image will be formed behind the mirror. These two light rays will never intersect. But if you extend these two light rays, they are going to intersect behind the mirror. At this position, what will be formed? Image will be formed. A dash, B dash is the image. AB is the object. So where the image is formed? The image is formed behind the mirror, either due to the convergent rays or the divergent rays. Due to the divergent rays. Due to the divergent rays. So where the image will be formed? Behind the mirror. So virtual image cannot be caught on the screen. Erect image, very, very larger in size. Virtual image, erect image, very, very large in size. These are the 6 important positions of the object for the formation of the image in case of concave mirror. Along with ray diagrams we proved. The first position, when the object is kept at -infinity, where the image will be formed, the image is formed at, that is principal focus, real image, inverted image, smaller in size. First position. Second position, if the object is kept beyond the center of curvature, then the image is formed between the principal focus and the center of curvature. Center of curvature. Real image, inverted image, slightly size increases. Third position, the object is kept exactly at C. Exactly at C, center of curvature. Image will be exactly at C. Real image, inverted image, size will be of same size as that of the object. Fourth position, if the object is kept in between F and C, principal focus and the center of curvature, where the image will be formed, the image is formed beyond the center of curvature. Real image, inverted image, magnified image, magnified. Fifth position, when the object is kept exactly at C, exactly at center of curvature, where the image will be formed at infinity. Real image, inverted image, magnified image. Last position, between F and B, principal focus and the pole of the mirror. Image will be formed behind the mirror. Virtual image cannot be caught. Real images can be caught on the screen. Virtual image, erect image, very, very larger in size. Larger in size. This is about the formation of image by means of concave mirror. U is the object position. V is the image position. The same table is applicable for convex lens also in the refraction. In case of convex lens also, same table is applicable because concave mirror, convergent mirror, convex lens is also convergent lens. Convergent lens. So have it. We will move to the next one, that is mirror formula. By using this table, we can derive the mirror formula. Now, the important derivations in the case of mirror. Mirror formula. What is mirror formula? The mirror formula is nothing but it gives us the relation between the focal length of the mirror, object distance, and the image distance. Image distance. Mirror formula gives the relation between focal length of the mirror, object distance, and the image distance. F is the focal length, U is the object distance, V is the image distance. The formula which gives the relation among these three is the mirror formula. First, directly we will write the formula, then we will derive. 1 by F is equal to 1 by V plus 1 by U. Mirror formula. Relation between focal length of the mirror, object distance, and the image distance. Image. For board exam, derivation also important. First, ray diagram. Ray diagram. I will take the concave mirror only. Sir, why you take concave mirror? Why can't we take the convex mirror? We may have a small doubt. Concave mirror forms the real images can be caught on the screen. Convex mirror forms virtual images. Virtual images cannot be caught on the screen. So in all the derivations, we consider the concave mirror. Let us consider the concave mirror. P is the pole of the mirror. C is the center of curvature. Join the pole and center of curvature by means of a straight line. This is principal axis. Principal axis. F is the principal focus. Principal focus of the concave mirror. As usual, PC, the radius of curvature. PF, the focal length of the mirror. Focal length. Now itself we derived a table where the object position, where the image will be formed. From that table, I am taking the second position. Second position. That is, the object is beyond the center of curvature. AB represents what? Object. AB represents object. Now form the image. Image. So how to form the image? So the image can be formed by means of 2 or 3 light rays by following the rules. The first light ray passing through the parallel to the principal axis. If the light ray is falling onto the mirror parallel to the principal axis, after reflection, it passes through the principal focus. This is the first light ray. First light ray. Consider the second light ray. Normal incidence. Normal. What is normal incidence? Normal incidence is nothing but the light ray passes through the principal focus, falls onto the mirror, and once again reflected back. Second light ray. Second light ray. What is the second light ray? Normal incidence, passing through the center of curvature, reflected back. Now the image can be formed. But for the derivation, I want one more light ray. For the derivation, I want one more light ray, which is falling at the principal focus by making certain angle. Following the law of reflection, after reflection, it will make the same angle. Angle of incidence is equal to angle of reflection. So all these three light rays are meeting at this position. Here what will be formed? Image will be formed. A dash, B dash. Formation of image when the object is kept beyond the center of curvature. Center of curvature. I am taking three light rays. The first light ray parallel to the principal axis. After reflection, passes through the principal focus. First incident ray, first reflected ray. Second incident ray, passing through that is what, center of curvature. After reflection, retraces its path. It is normal incidence. The third light ray, after reflection, makes same angle. Therefore, in this ray diagram, what represents AB? AB represents object. What represents A dash, B dash? A dash, B dash represents image. Image. If you see properly, the object is kept beyond the center of curvature and the image is formed between the center of curvature and the principal focus. This is center of curvature, beyond center of curvature. Image between center of curvature and the principal focus. Principal focus. What is the image? Real image or virtual image? Real image. Inverted image. Smaller in size. This is the size of the object. This is the size of the image. Image. Then what represents PC? P to C. PC is the radius of curvature. Radius of curvature. By using sign convection, I can write its value also. Light ray is falling like this. We are measuring from P to C. If we are measuring from P to C means opposite to the direction of light ray. If we measure opposite to the direction of light ray, the sign convection, negative. So BC, radius of curvature, minus R. Minus R. PF, P to F. Focal length of the mirror. Focal length of the mirror. What is the focal length of the mirror generally? Smaller. Where to where? Principal focus to or pole to principal focus. But light ray is falling in this direction. We are measuring the distance opposite to the light ray. According to sign convection, once again, the focal length is negative. minus F. Minus F. Then what is PB? All the distances in optics, spherical mirrors, measured from the pole only. P to B. So P to B. AB is the object. If AB is the object, then PB is nothing but object distance. Object distance. So PB, object distance. Object distance. U, but sign convection, opposite to the direction of light ray. If it is opposite to the direction of light ray, it is negative. Minus U. Minus U. P to B dash. P to B dash. A dash B dash is what? Image. Image. Therefore, P to B dash is the image distance. Image distance represented by V. So image distance represented by V. But what sign? Minus. Why negative? The negative because we are measuring the distance opposite to the direction of incident light ray. So ray diagram completed and also the values are completed. So tomorrow I will discuss the derivation part. By considering the similar triangles, we can solve the derivation part. We can prove that 1 by F is equal to 1 by V plus 1 by U. 1 by U. Have the snapshot or take down properly. So thank you. Have a good day once again tomorrow.